All right, so today what we're going to be working on is exploring the graph quadratic equation. So this is out of our packet. You guys don't have this packet. This was after we had left school. So I'm going to run through the notes. Feel free, definitely, writing notes while while I'm giving the notes will help you remember if you write them down. It's positive. It's good for you. So if you want to do that, you can. I can put up a blank copy of this form if you guys would like to do the notes. So I'll put that up along with this assignment. So basically, quadratic functions are written in the form, and this is our standard form. There's another form that we're going to be doing, but right now it's, we have ax squared plus bx plus c. All right. So that's our standard form. So the x-intercepts, right? Our x-intercepts when our y equals 0 of the parabola, right? So we get a parabola when we use the quadratic equation. Are called so we'll call them either the roots or the zeros. All right. So if you're on the regions, they'll ask, find the roots, find the zeros. But for both, they're basically they're the x-intercept, right? They're just two different words for the x-intercept. So on this, they're saying how many roots, if we have a quadratic, right? And this is our parabola looks like this, right? This is our parabola, not a smiley face. So a parabola. So it's saying, okay, if we draw a parabola, how many roots are possible to obtain from a quadratic equation? So if I drew it like this, let me see, I'm just going to draw a couple of these. And let's see, we'll draw them like this. Okay, so basically what this is asking is how many roots do you have for each one? So on this, I've got, a little bit off, but I've got two roots, right? I cross the x-intercept twice with that particular parabola. So I can have two roots. I could have just one root. Oh, right. If it crossed right there, I could have one root. Or this doesn't cross the x-axis at all, so there's no x-intercept, so this is 0 roots. All right, so parabola, we can have two roots, we can have one root, or we can have 0 roots. Okay, and they'll be asking us questions while we're going. All right, so given the following graph of the equation y equals x squared minus 7x plus 10, answer the following question. So only look at the graph to answer the question. So we're not going to figure out what our axis of symmetry is and what our vertex is algebraically. We're just going to look at our graph and determine what it is. And we have some practice with this already. So our axis of symmetry is the line that goes right through our vertex. And I'm just going to, it's more difficult to do it like this on the computer than you would think. But so it's a line that goes through the vertex. All right, I'm going to do a dotted line just to make sure I don't do too bad. So if we look at this, it's a mirror image of itself. I could fold this parabola, and this arrow would end up on that arrow along this axis of symmetry right here. So for this example, the axis of symmetry is at 1, 2, we're at 3. I'm going to call this, it's at 3.5. Right, so my axis of symmetry, remember this would be one of those cases we have a vertical line, so it's Vux. So we do x is equal to the x coordinate there, right? It's a vertical line, undefined slope, all that good stuff from linear equations. So this is going to be 3.5. Okay. Next, it says what are the coordinates of the turning point or the vertex, right? So another word for turning point is vertex. So the vertex is right here. And if we look, we already know that our x value is going to be 3.5. So we know that we have an x coordinate of 3.5. And then we look to see what is our y value. So we go down to 1, 2. So we're at minus 2. All right. So that is our turning point. It says, is a turning point a maximum or minimum point? So this is something we haven't covered at this point, but it basically is saying the lowest y value, right? When your parabola is facing up, your vertex is going to be your lowest point. If it was going this way, right? If we had a parabola that was going like this, our vertex would be our maximum. Okay, so this is just asking, okay, is your vertex, is it a minimum or is it a maximum? Is the parabola facing up? If it's facing up, it's going to be a minimum. If it's facing down, if our parabola faces down, our vertex is a maximum. Y value doesn't get any higher than that. So the turning point in this case is a minimum. All right. It's asking how many roots do we have? So we've got one right there, one right there, crosses the x-axis twice, 2 roots, 2 zeros, 2 x-intercepts, basically all the same. So we've got 2, and it says, what are the solutions of this equation? So it's asking for what are the x-intercepts, right? So our solutions, we can say x is equal to, and we're going to use brackets to signify, that we have a solution here. So I just list out what my 2 x-intercepts are. So 1, 2, so I've got my x-coordinate for my first x-intercept is 2, and then 1, 2, 3, 4, 5, and I've got 5 as my second x-intercept. So when it's looking for the roots, when it's looking for the zeros, when it's looking for the solution, it's looking for what your values of your x-intercepts are, your x-coordinate for your x-intercepts are. So 2 and 5. And saying, oh, what are these solutions called? So these are called my roots, right? Okay. Now solve the equation by factoring and t-charting, right? So on this one, we would use our AC method, and I don't want to use too much of this is a review. We've been doing this, but AC goes, my A is 1, my C is 10, so factors of 10 that add up to -7. All right, so factors of 10, I know I have the same sign. This plus sign tells me I have the same sign. The one in front of the B tells me that they're both negative. So I know that I have a -5 times a -2, right? -5 times -2 gives me +10. -5 plus -2 gives me a -7. Basically, to save time, and we've done some review recently of this. I'm not going to go all the way to the end with this, but basically at this point, you guys would know to take your x squared, right? You're going to go minus 5x. Remember, I like to use that plus sign to separate, and then go with the minus 2x, and that'll help me when I get to the grouping part. And then I go plus 10. Okay, and then from there, this is where you're just going to group, and then you're going to pull your your greatest common factor out, basically, right? So out of your 2 terms here, what's your greatest common factor? It's going to be x out of this one, so you'd pull an x out of this one, and out of this, you'd pull a -2 out. Okay, so you guys can finish that one off. We're going to move down to our second example. Again, the AC method, we've been doing that. That should just be some review for you guys. So let's take a look at this one. So we've got example 2, graph y equals negative x squared minus 6x minus 5. It's saying what's the axis of symmetry? What are the coordinates of the turning point? All that. So we could make a table, right? One of the things we could do is we could go, okay, I can put my x here, right? Just like we did with functions. We could list this out, negative x squared minus 6x minus 5. Okay, and then it basically says what are my y values. And I could put, I could just guess and go, okay, I'm going to go 0, -1, -2, put it in for each one, but we have got a graphing calculator, right? And so I put in the assignment, I put a link into different graphing calculators. You can always use Desmos, which is another one that we have if you're online. But let's try this one with the, I got this Texas Instrument emulator that's just like our calculator that we had at school. So if I go to my y equals button right here, I press on that. I still have things in here from a warm-up. So let me just clear that out. So I'm going to put in a negative x squared minus 6x minus 5. All right. So, I can graph this, see what it looks like, see if I can figure it out from there. Or remember, if I do second and then I hit graph for that table, now I can just sort of take a look at this and go, okay, right here, I see that I have a turning point, right? -5, 0, -4, 3, -3, 4, -2, 3. So we have our turning point. Our vertex is right here. And then everything is, that's our mirror image. We've got a 3 and a 3. Our y values are mirror images of ourselves, -5, -5. So I'm just going to, because as soon as I click on the sheet, this will all go away. So I'm going to say -3, 4, -4, 3, -5, 0, -6, 5, -5. Whoops. And then on the other side, it goes 0, 3, 4. So then we have -2 is a 3, -1 is 0, and 0 is -5. Okay, so I could fill out, like if you're on your Regents, you could fill out your table at this point with those values. I can go, okay, let me just use the eraser. So if you have like a part 2, 3, or 4, you can just go, okay, from my calculator, I got -6. It tells me it's -5. This one was -5, which is 0, -4, gave me 3, -3, gave me a 4. -2 gave me a +3, so this is the mirror. -1 gave me a 0. Just 0 gave me -5. All right. So we know from an earlier lesson, right? We've got that negative sign that I just covered up. All right, we've got this negative sign right here. That tells me it opens down. All right. Let me erase this and do this again. All right. So it tells me that it opens down, right? When I have a negative in front of that x squared. Okay. Also, another thing that we can use to help us out, this c term. I think we went over this last time. That tells me that that's my y-intercept, right? So I could just graph the points, but this tells me my y-intercept is 0, comma, -5. All right. So all I have to do now is go, okay, 0, 1, 2, 3, 4, 5, and graph it like that. -1 was 0. -2 was a +3. 1, 2, 3. -3 was a +4. -4 was a +3. -5 was at 0. -6 was all the way at -5. All right, so we've got our points there. I am going to try to draw this now. So I'm just going to put an arrow down. All right, so there's my parabola. Okay, so it says, what's the axis of symmetry? So I know that, here's my vertex, right? My vertex is -4, 3. So my axis of symmetry is going to be that -4. So our x is equal to -4, right? We do a vertical line for Vux because, again, this is where I have a mirror. I can do a mirror image of this parabola. If I folded it in half right down this line, the arrows and everything else would match right up with each other. So that's where, whoops, I'm sorry. All right. All right, let's see if I can cut this part out. But if I can't, I apologize. So I was trying to do it quick. And when I looked at it, I'm like, that doesn't look right. It's supposed to be 4 over -4. But so at -3, 4, that's my vertex. Okay. So this is where you just always want to double check when you're doing it. This is going to be -3, right? So if I go 1, 2, 3, that is my axis of symmetry. So -3, I apologize for that. The coordinates of the turning point are -3, 4. So again, right from my table, -3, 4 is the turning point, a maximum or minimum. So my y values don't go any higher on this. It's facing down, so this is going to be a maximum, right? My vertex is the highest point on that parabola. So it's a maximum point. How many roots are there? We got 1, we got 2, we got 2. What are the solutions of this equation? X is equal to, I'm going to do my bracket, and I go, okay, where do I have a 0 for my y value? And that's what my x-intercept is. So I've got -1, -5. All right, close the bracket. All right, and what do you call the solutions? We're going to call them our roots. All right, and now it says, now try to solve the above equation algebraically. How do we do this? So if we solve it algebraically, right, if I take -x squared minus 6x minus 5, all right, you can use the AC method for this. Definitely do it for practice. But remember from our last lesson, we know that our x-intercepts are basically going to be what our solution would be. So we're going to end up with x equal to -1, x equal to -5. Because this would be the same as, all right, with our roots. So I put my x in. If I look at my roots, I go, okay, it's at -1, -5. Remember, we had x equal to -1, which we did in our last lesson, at x equal to -5. If I add 1 to the other side, I get x plus 1 equal to 0. And if I go plus 5 to both sides, because this is a -5, I get x plus 5 All right. And if I did this out, because this is facing down, we have one more step that we got to do that I'm going to show you in a little bit. But basically, we can get our roots right here, and that's gonna help us out just to double check this. But you should end up with this answer when you do your AC method. You're going to eventually end up with what this answer is here. All right. I think what we're going to do, I'm going to stop and have you guys try a problem. So here is the problem right here. You have to graph y equals x squared minus 2x minus 8. You can use the graphing calculator app that is linked here, or you can go up to this Desmos site. So here it is right here, desmos.com/calculator. And you can put in your equation for that. But I want you guys to figure out the questions on this. All right, so I'm going to pause. You guys will do that question. All right, so now I'm going to go down and we will try a new, well, basically a review of our last lesson, but this is where we're trying to figure out, okay, what's our quadratic equation from a graph? So the steps for this example 3, right? So we've got example 3. The steps are, we're going to find the roots when the graph crosses the x-axis, put roots into factored form, do our double distribution, put in correct quadratic equation form, okay? And this is where it says, watch out for open or down parabolas. So like on that last one, I was going to go through and show you, because I was facing down, it has like an extra step to it, and we're going to do that actually in our next example, and that'll be our last example for this lesson. But what we'll do is we'll get to that when we're seeing if we're opening up or down. Right now we're opening up, so we don't have any extra steps, so we're good to go. So we want to find our roots first step, right? So there's our one root, there's another root. So this is x is equal to 1, and x is equal to 1, or 1, 2, 3, 4. All right. So x equal to 4, x equal to 1. So now, let's use that T diagram that we had started off with before. And you don't have to, you can skip this step if you understand how to do this part. But basically, you're just going to do the reverse of this, right? When we solved it, we had to solve it. It was, it was equal to 0, right? We had everything equal to 0 to find what our intercept was. And then we had x equal 4, right? So if we want to do the reverse of that, we got to bring the 4 back to the other side with the x, right? If we had done the AC method, we would have done our t-chart, gotten all the way down, and then we would have had x minus 4 equal to 0. Okay, and on this side, we've got, man, I'm making mistakes all over the place. This video is already too long. So this is actually x is equal to negative 4. Okay. All right, x negative 4, so instead of subtracting it, we're going to add the 4 to both sides. Okay, so add the 4, and we get x plus 4 is equal to 0. And on this side, we have x is equal to 1. We subtract the 1 from both sides, and we get x minus 1 equal to 0. But now we can go and multiply these two roots, or just before the roots, times each other. So we can either use the FOIL method or we can use the box method. So I know a lot of you like the box method, so we'll do that. So remember, we do a box. So my x plus 4 goes here. My x minus 1 goes here. I'm going to change colors. So we have x times x gives us x squared. X times 4 gives us 4x. X times negative 1 gives me a negative x. 4 times negative 1 gives me a negative 4. All right, so I can rewrite everything that's inside there. X squared plus 4x minus x minus 4. All right, I'm going to combine the middle term, x squared plus 4x minus 4x, or plus 4x minus x gives me plus 3x minus 4. Okay, so that's how I can get back to the quadratic equation. Standard form is I use my intercepts, my roots. I work my way backwards, and I got to put it in standard form, so I got to definitely simplify this middle term. So what I'm going to have you do is I'm going to stop and have you guys try this question. So look at your roots. Looks like this one. You're going to have a negative 3. Make sure you do negative 3. Now, don't make the mistake like I did. So negative 3, positive 2. Okay? So you guys try that, and then we'll come back. All right. So you guys just tried that one. We're going to move down to our last example of the day. All right. So this one right here is an upside, or it's a going down, right? It's a parabola that's going down. Here is what my x-intercepts are. So I've got, here's my origin. So 0's right there. So I got a negative 2, 1, 2, 3, and a positive 3. So x is equal to 3. X is equal to negative 2. All right. So on this, we go x is equal to negative 2. All right. We can do our t. X is equal to 3. We just have to get the number. This, normally we're solving always get x all by itself. In this case, we're working backwards, so we're going to bring the number back over to the other side with the x. So I'm going to add 2 to both sides. And I get x plus 2 equal to 0. And then on this side, I'm going to subtract 3 from both sides. Subtract 3. I forgot my wall. And I get x minus 3 equal to 0. Okay. Now I'm going to multiply these two together. I go x plus 2 times x minus 3. We'll use our box. Let's see. All right. Let's take the top off this box. It's a little too close to the equations. All right. So here we go. So I have x plus 2. X minus 3. Now I go x times x gives me x squared. X times 2 gives me 2x. Negative 3 times x gives me negative 3x. Negative 3 times positive 2 gives me a negative 6. Okay, so I'm just going to change my color. So I'm going to end up just rewriting what I got inside. X squared plus 2x minus 3x minus 6. Okay, I got to combine this middle term, so it's a positive 2x, or simplify 2x minus 3x. So I end up getting x squared minus 1x minus 6. Okay, so remember the rule, right? When we have, I'm just going to put the rule over here. If I have ax squared plus bx plus c, right? Ax squared, so that's my quadratic equation. If I have if a is positive, then the parabola points up or opens up. If my a is negative, my parabola opens down. Okay, so when I did this, I have an a term here that's a positive 1. So this parabola actually opens up. So if I had x squared minus x minus 6. So if I was to graph this, right? Let me do this real quick. So we go into y. If I clear this and I say x squared minus x minus 6, and I graph it, it's going up. So what I need to do is I need to make this a negative x. So what I'm going to do is just multiply this whole thing by a negative 1, because I want to make it a negative x. I want that to be a negative x squared so that it's facing down. So now I'm going to distribute negative 1 in. So negative 1 times x squared gives me negative x squared. Negative 1 times a negative 1x gives me a positive x. Negative 1 times negative 6 gives me a positive 6. Okay. So let's take a look. So now let me put that in. So if I put that in, I go down. Now I have a negative x squared plus x plus 6. And now when I graph it, boom. So you'll see that red is this one, right? So they have the same exact x-intercepts, the same exact roots, but when I put the negative in front of it, I change the signs on each term, and it opens it down. The original one that I came up with had it all opening up. So then, like, that's the one step that you have to remember. Like, always look back at your graph and say, okay, it's facing down. So now I got to multiply each term by a negative in order to make that first term negative. Okay. So now I'm going to have you guys just do a little bit of practice with that. So you got one question on that. So I do have, I know both these videos, my warm up and this one have been long. I have a quick exit ticket, and then you guys are good to go. Okay. Thank you very much. So try this and then go on to the exit ticket.